Hello and welcome everybody to the Big 5G's transport track. And this session is focused on a closer look at the disaggregation of transport networks, focused on the very hot topic of transport and disaggregation, two hot topics coming together. And we're really going to focus the discussion around how disaggregation is applied to areas of where 5G transport comes into play. This would include front haul, mid haul, back haul, which we collectively call the X haul segment, as well as other transport areas as well may come into play, but always in the context of how does this relate to a 5G network build and rollout. My name is Sterling Perrin, and I'm a principal analyst with Heavy Reading. I focus on transport networks and have spent a good deal of the last 3 or 4 years looking at the evolution of 5G. So I'll be the host and moderator for today. We have, I guess, about 40 minutes, and we do have a panel of 3 experts, which I think you will find a lot of value in their comments throughout the course of that 40 minutes. I'll introduce each of them here. I'll let them each give a little bit of introduction of themselves, their role, their company, and then we'll just jump into the discussion from there. And I'll start with Layli Amiri. She is lead member of the technical staff with AT&T. Welcome, Layli. I know everybody should be very familiar with AT&T, but maybe if you want to make a few comments about yourself and your role within the organization so people know your perspective.
Thank you, Sterling, and I'm really excited to be here today. I'm actually a fan of your webinars. I have over about 30 years in the industry building larger scale networks. The last 10 years of my career has been dedicated in building 5G transport, transport network for mobility. Focus right now is really transitioning from the transport used for LTE to 5G and potentially beyond that.
All right, excellent. And Layli will be joined today by Andrew Bender, CTO of DCS. Andrew, welcome. And if you want to say a few words of introduction, I'll let you have a moment.
Okay, thank you, Sterling and team. It's great to be back on the trade show circuit here, so excited to be part of this event. I'm Chief Technology Officer of DZS, as you mentioned, lead the technology team here. Our company, we are a specialist and industry leader in mobile transport. We're actually part of one of the largest O-RAN 5G network deployments that's been out there to date. We also do work in broadband access, SDN, software automation, which is relevant to our topic today. My history has been with telco and mobile for many years, but in many cases on the software side, prior to DZS, companies like VMware and Hewlett Packard Enterprise have focused in this area as well.
All right, excellent. Welcome. And then last but not least, Alan DiCicco, Senior Director, Emerging Solutions and Market Strategy with Calix. Welcome, and give you a moment to introduce yourself and your company.
Thank you, Sterling, and the fellow panelists. It's great to be here. And adding to what Sterling said, I've been at Calix now for quite some time and really focus on emerging technologies and applications. I'm a bit of a expert, subject matter expert in next generation PON, and particularly as how that rolls over into 5G solutions. If you do a mental map of a 5G network, you'd find Calix solutions way out at the edge of the network, right? We might be attaching to the cell site router or deeply embedded in the RAN transport layer. We kind of stop at that point, so you won't find Calix solutions in the more transport, if you will, part of the network.
All right, excellent. With that, let's jump right into it. Layli, we'll kick off with you. AT&T has tremendously high profile, not just in the U.S. but globally, with really pioneering a lot of work in disaggregation. So I'm sure the audience, myself included, would like to hear about what's driving disaggregation specifically in the AT&T transport networks and for mobility.
Sure. So I have 2 answers for you, a long answer and a short answer. So I'll start with the long answer first. As a service provider, we typically refresh our network every 5 to 7 years. And when it came to 5G deployment, we realized that we were due for a network refresh. And 5G brought its own challenges for us also. We had to care for low band, mid band, millimeter wave. We still have LTE and 3G to care for in the network. So we needed a platform that was extremely flexible in this space, scaling down to 100 megabits per second and up to 100 gigabits per second. At the time when we look at industry, we realized that merchant silicon was going to give us that flexibility we needed. It was a highly reliable platform, and also it came at a much lower cost per gigabits per second. So we started looking at merchant silicon. We actually put in spec based on merchant silicon to open compute, which allowed us a good transition plan from 3G LTE into higher bandwidth requirements that came with 5G. We ended up using that merchant silicon platform for our cell-site gateway routers. We use our own Viado NAS platform, which is very feature-rich also. There is an open source version of that, DNS. Anybody can use that. Since then, we've deployed over 18,000 units in production. I believe this is one of the largest deployments of disaggregated router in mobile world. We have extended disaggregation from our cell-site gateway routers to our aggregation layer since then. We're using also merchant silicon and white boxes. Again, this gave us the capability to drop our unit cost significantly. We're using these disaggregated routers in a form of Lego building blocks. We're building complexes based on white boxes. We can scale up for larger markets and scale down in a smaller market. So it's given us a lot of flexibility. And really the disaggregation allowed us to look at things a little bit differently. It has simplified our sourcing activities, our inventory system, our sparing policies, our provisioning tools, by allowing us to use the same hardware in different modes and different applications. We can think about it, use a hardware platform with different NAS or use the same NAS on different size white box platforms. So really that capability and that flexibility streamline our processes and operations and our tools. Not only streamlining that, but also there's also a TCO aspect associated with that. We have since then used the same platforms, as I said, in different applications. For instance, our cell-site gateway router, when our customers came in to deploy mobile edge compute, we realized that they had a lot of different routing requirements, and the same platform that we use our cell sites, we use it as a mobile edge compute access router. Again, the flexibility was there. The hardware supported all the feature requirements. The software could be used with different configuration to meet the always changing requirements from our customers. So this actually gave us a lot of flexibility in that space. So this was my long answer, not the short answer. The way we look at disaggregation is really a tool in the toolbox for the operators. I think each operator needs to look at this from their own point of view. How can you simplify your inventory, your sparing, your IT and OSS development, your total cost of ownership? And that's really where the flexibility comes in.
All right, excellent. I'll bring in both Alan and Andrew in a moment, but maybe two follow-ups with you before we go there. First, you mentioned the 18,000, which is interesting. Can you give a sense of, what's the end game number? I don't know if that's public. 18,000 out of, but like how far along is that towards where you want to go, maybe as a percentage or however you could present it?
Sure. As you know, AT&T network is got a quite large footprint, and we continue to deploy the disaggregated cell-site router. At the moment, this is our flagship platform. I don't know where the end game is going to take us, but at the moment, we continue to deploy this platform for near future and probably extended future.
Great, that is helpful. And the other question was, you just mentioned the routers you have in your network already. What is the impact of your move to disaggregation on the traditional established architectures for transport? I guess specific here to the backhaul networks.
It was about, as I said, this is a network refresh, right? I mean, we didn't really change the architecture of the network by going to disaggregation. We still use the same transport mechanisms. What happened between LTE and 5G was that we needed to go from platforms that were literally low speed, 100 meg, 1 gig, to something that could scale up beyond 10 gig. And this disaggregation allowed us to do that at a pretty decent cost per gigabit. So the architecture didn't change, the speeds changed, I think, more than anything else.
Interesting, good point. Let me bring in Alan and Andrew. Andrew, I guess I'll start with you and then Alan, but kind of the same questions, but more as you look at your full customer base. Wondering how much of what Layli talked about resonates in terms of what you're seeing for drivers for disaggregation, as well as the comments about the impact on traditional architectures.
Yeah, sure. So all good points. Obviously, AT&T is an early leader in this approach of having a disaggregated transport network for cell site router equipment. We've been working in this area for many years, and I think as Layli just said, even as we deploy the new architectures, there's going to be existing platforms deployed in the network. So a fundamental question there is the capabilities that you have in both platforms from an operational software features perspective, how you make those transferable into this new architecture, and we've spent a fair amount of time on that. I'll talk about that probably a little later, but. One key concept that was mentioned already is the notion of convergence. In cases where carriers are both providing 5G networks and also broadband optical networks, for example, sometimes we call those 10G networks, there's a desire to have a common architecture in the access network or to support multiple types of services simultaneously, like Sterling, you mentioned mobile xHaul. As well as 10 gig and above class PON, passive optical network technology that you might use in what used to be the old wireline broadband network. So the fundamental question is how do you create a platform that can serve both of those applications and have both sets of software features? One of the key ideas behind the disaggregated approach is not just supporting open hardware, that's a key question, but it is also software velocity. How do you introduce new services? How quickly can you change the network, introduce new capabilities, and so forth? So I would say that's one of the key drivers, in terms of customers who are embracing this new world approach of how to deploy cell site routers, what we used to call cell site routers. The other key driver, and I think question that we see is densification. Certainly those macro eNode, gNode sites, they remain where they were before. They'll have to be upgraded. But when we look at these higher frequency bands, smaller cell diameters, increased population of cell sites, small cells becoming prevalent, that changes the architecture of the network. It means that you'll need mobile transport and in a lot more places than you had it before. You'll need to go deeper into the network with higher order transport. Like we mentioned, 10 gig and above being the new benchmark of what you need to do for backhaul. That's even true for small cells and indoor systems at the millimeter wave bands, right? So we see that as being a key driver because with that large quantity of network elements and sites, there's this question about how do you control, manage, and scale that network. So those are the two big drivers that we see.
All right, excellent, good comments. Alan, I'll let you wrap up on both the fronts. As much as you'd like to address them. One, the drivers that you're seeing from your customer base, and two, how the traditional architectures are being impacted.
Yeah, no, thank you, Sterling. I think I view disaggregation not as somewhat as the driver of the events that are happening, but a bit of a name we're hanging on functional decomposition or better architectures that was going to happen anyway. That's been constantly happening. We have engineers who is their life, work to create better networks, better integrate new technologies, better integrate, network programmability. And so just as system vendors, Andrew and our companies have worked on our own products and the bottlenecks and incorporation of new technologies. Every time we build a new product, every time we contemplate integrating a new technology, you can extrapolate that up to the network. So we are disaggregating complex systems because it fosters faster innovation or better scalability or flexibility to incorporate the latest technology, not because we woke up one day and said, let's disaggregate. We're doing these to get from one point of optimization to the next point of optimization. And once we do this, we'll move to the next point of optimization. So every industry is going through that process. So I think that, to me, is fundamentally the driver for disaggregation and transport networks. And to some of the things Andrew said about also consolidation of functions and services, getting more for your network, more uses out of it. In terms of changes to the established architectures, I think Layli said something like, fundamentally, the network is not changing. The way you build it down at the network element perhaps is, or the way you control it. You're still using transport between sites. You're still using mesh architectures, to connect different sites and regional networks and local networks. And so I think there is somewhat of a misconception that somehow the network itself is radically changing. I think the way we're building it together, and Lego, I liked your analogy, Layli, about Lego block building up. The final thought I'll give on this kind of topic is disaggregation is a spectrum. It's not a binary process. In different parts of the network, the core, data center interconnect, we're seeing much more rapid adoption than we are as we move further to the edge. I think you can by and large say the more complex the hardware, the more demands you place on it, the more unit function it starts out in life, the harder it is to find some new optimization well point for it. What we've seen, what Calix has experienced, is the first step in our evolution of disaggregation was kind of throwing out the old operating system and building a whole new operating system that had, was based on NetConf Yang data models and interfaces. We moved from a world of SNMP and network management systems to programmability, and we've massively moved forward in network transformation and disaggregation through what sounds like a really small baby step, but is really a huge fundamental step. And so there's this process that every segment, every hardware is moving along in every bit of the network.
Okay, we will move on in a second, but Layli, I don't know if you have any final comments on this, or?
No, not at this time.
Okay. Great. Let's move on. So, another big topic around 5G and in the industry is you can't talk to really any operator, go to any conference without discussion about the edge cloud. So we'll bring it into this discussion. Andrew, I think I'll let you take this one, but not so much the importance of edge cloud, but really what's the role of disaggregation in our topic here as it relates to these strategies, which we know are crucial for operators to move to edge cloud. What's the role of transport, disaggregated transport?
Sure. Well, in terms of why edge cloud is relevant to the discussion, we do see in a decomposed or disaggregated radio access network the emergence of this edge cloud that you described taking over for where there used to be baseband units in the radio access network, which in turn connect into the core through through cell site router like platforms that could be disaggregated as well. One of the things that Layli said is that MEC like platforms, cell site router use cases, they're all opportunities to embrace this disaggregated model. What we see in general is that the network is becoming increasingly software defined and software driven. So a lot of the things that used to be physical network functions, embedded devices are becoming software based, and that's giving rise to this edge cloud idea. When we look at disaggregation from a transport perspective, fundamentally that entails taking some of the control plane intelligence that we used to have in edge routers, switches, and so forth, and putting that up at a higher level in the network. But that also drives a question about, can you make these things self-contained or standalone? What do you do about high availability if you have intermittent connectivity? So we see an edge cloud as being a great venue to have the software-based control plane that you might have in a disaggregated design. I think that's a key aspect here. We mentioned the software and service velocity. In the edge cloud idea, there is a notion of being close to subscribers, having low transit latency. As we make virtualized radio access networks, that becomes an important technical requirement. So if your control loop is shorter, you need to be closer to the devices that you're actually controlling. So that's where I think edge cloud comes in.
All right. Maybe just a couple quick follow-ups. Well, just to really encapsulate the role, Andrew, would you say, as we look at the rollout of edge cloud among the operators, would you say that disaggregation is essential? Like they will all need to move to disaggregation, or you think it's important, or is it just going to be kind of a mixed bag, operator to operator? And we won't hold you to it 5 years from now, but I realize we're well in the realm of speculation, but just curious your thoughts.
Well, many operators are opinionated here, and they're each setting a different course for how fast they're going to go, how deep in the network they're going to go with software defined. So we need to have architectures that support that. I would say there's a natural opportunity if you do have an edge cloud strategy, and that has been realized, to use that for disaggregation in the transport world. If you already have what is in essence an edge data center or some edge network intelligence, that's a great place to run the routing control plane. Thinking back in our heritage, probably Alan's and I, and being hardware guys over the years and things like that, there's always this fundamental design consideration when you're going to make an embedded network device. How much control plane intelligence, how much CPU smarts do I put there? And that places a premium on, we have to get right, either too small or too much, it's too expensive. But disaggregation is freeing in that regard, in that we still have some smarts in the device, but if we need more smarts, we can just go to this cloud that's right next door and get it. And that really opens a whole world of possibilities for how we impart intelligence to the network.
All right, excellent. Alan, anything to add on that one from Calyx's perspective?
No, I echo a lot of Andrew's thoughts there on the evolution of edge computing and the role edge is going to play in 5G. I like to, people who don't have a lot of background in 5G hear the popular media talking about 5G is lowering latency and improving latency, as though somehow the speed of light has changed because we've adopted 5G. And I think there's this idea that, no, we're actually just moving the content and the computing, and, we're changing the goalpost on one end. There's not fundamentally that the wavelengths through the air are moving faster. I think edge computing is a wealth of opportunities, and I don't think you can decouple the routing, the transport, everything that's going to be used to connect those out to the subscribers.
Yeah, it's a good point. And I think very early on, it seemed like the the latency was sort of solely a transport problem with the ultra low latency communication, which is part of 5G, of course. But I think people quickly realize that the locations do have to. There's a physical thing that's moving, and that edge needs to physically move, regardless of what sort of technology is being applied to the radio devices and the transport, which can help. But if you don't move the content, the storage, the compute, it's useless. As you say, the speed of light is not changing anytime soon. Let's any further comments on this one, or we'll go to the next one. All right. This and again, for the audience, this is sort of a quick survey of disaggregation. I recognize any of these topics we could probably spend a whole session on, and I'm sure you can follow up with our panelists post event for further thoughts and views. The one I wanted to move to now is challenges. So we talked about drivers, and then the other basic thing we look at as analysts is challenges. We've done a fair amount of survey work on this topic around disaggregation, and there's really two that bubble to the top around disaggregation, pretty clear, standing out. One of them is the maturity of the technology and the availability of features. We sort of hit on that a little bit within the drivers. You need to meet what's required, or it's no point to go to disaggregation. We can certainly spend a little bit more time here talking about that. The one I wanted to zoom in on the most, though, is on the operational issues that operators are finding as they move to disaggregated architectures, regardless of the technology evolution. If the operations aren't, changed or ported or adjusted to use disaggregation, it's not going to work. And I want to take this opportunity with AT&T and Laley, since you guys have pioneered so far into disaggregation, and as you said, you've got a number of routers out there already. How are you? What have you encountered, I guess, operationally with disaggregation, and then even equally important, if not more, how have you guys tackled some of these issues that a lot of operators are still saying are challenging for them?
Sure. I think, first of all, it's a mindset change for both the operators and the vendor community. When you look at disaggregation, you have to manage both your separate software and hardware applications and vendors. There are different models that could be applied here. One model would be that you get your vendors to manage an end-to-end solution for you, or you can get an integrator that would integrate and manage your supply chain process. In fact, we went with the option of a third-party integrator for that, and they support our operations by managing the hardware and software integration process for them. So that's one aspect. The other aspect of some of these challenges is that as a operator, you end up working a lot closer with your software and hardware vendors. Overnight, you become experts in both software development and hardware development. And this has been quite an exciting, actually, challenge. We have been kind of getting visibility at the subcomponent levels. As a result of that, our development cycles get better because we understand some of the challenges that exist for our vendors. So that relationship is a much stronger relationship. And people ask us constantly, how will your hardware and software vendors work with each other? Because now you're managing even more vendors here. And our experience has been that our vendors have always supported us very well, and everybody has a desire to succeed. So this is not any different whether you disaggregate your hardware and software or not. I mean, everybody supports each other in this transition plan. Another important point I like to bring up is about implementing DevOps and following DevOps model. We had our operations team work with us during the design cycle, during development cycle, during certification and implementation. We got continuous feedback from them. We had our software development team and operations team work together to develop features that they needed for automation. So really relying on DevOps is really important in addressing some of the operational challenges that industry is concerned about. As they say, it always takes a village to do anything. So we have an amazing group of engineers in our operations, in our software development team, with Viada in our IT development teams, architects, network designers, everybody just, hand in hand work together to make this happen for us.
Okay, so despite challenges, AT&T would certainly call this a success story at this point.
It's a success story.
Yeah, good. Alan, from Calix side, what you're seeing, I guess just challenges broadly, and if you want to comment on the operations issues as well, but Layli certainly did a good overview.
Yeah, real quick point on operational challenges. Again, where Calix sits in the network, we are much more closely associated with subscribers, individual subscribers, and inherently then there's many more people involved on the service provider side to deploy and manage that side of the network. And so I could probably argue easily that getting the technology and the software right is actually really fairly easy versus the methods and procedures, the small army of field technicians and people that need to be trained and central office engineers. That, I think, is the operational challenge that kind of cascades as you move further out. Now, 5G is a smaller problem to solve, but yet, as you start thinking about the density of small cells going out into the field, what are the implications? Is that strictly a deployment operations, or how much does that scale back into operations and support and troubleshooting? So not insurmountable. I think you just have this appreciation for the expanding role of operations as you move further out to the edge. Technology challenges, I think there are a couple, not so much of disaggregation, but still within the RAN, as we look at all the optional splits that are still under discussion or being debated or selected and chosen by different technologists or service providers. Some of those are levying pretty serious network timing distribution requirements or latency requirements across the front haul, what's appropriate for various transport technologies, a TDM technology like TDM PON, XGS PON, or do we start adopting WDM PON? So there are some small technical hurdles that are mostly related to the disaggregation of the RAN itself, not the transport and moving to a white box of controllers and such.
Yeah, that's a good point. I mean, you've mentioned several times the decomposition of the RAN. That is, would you say that is a form of disaggregation itself? They're always careful to say it's decomposition, but you are taking things that were unified and disaggregating them.
I'm not sure I would want to split hairs between decomposition and disaggregation. To me, it is, again, back to some really smart engineers have figured out a better architecture, and there are healthy debates for how to the decomposition of the RAN and the functional components, the integration of software controllers, that they're going to make this scale and be much more efficient. So I don't split hairs and try and think of them as different. To me, it's all disaggregation driven by decomposition of what was monolithic systems into something much more flexible and easy to deploy over time.
And it's a good point that the transport itself may not be disaggregated in these particular spots, but the role becomes more important for transport because these functions of the radio unit and the distributed unit and the central unit are now spread across something that requires a transport network in the mix, where in the past they did not, right?
Yeah, and even those definitions, mid-haul and backhaul, I think Andrew made this point, he might add to it, they're blurring a little bit. So one operator's mid-haul is another's backhaul, based on where that control function is. It's sort of a dictionary definition, not a impact on the technology at certain points. But I don't know, Andrew, if you want to add, it was your point on the blurring of lines.
Yeah, sure. Well, what we do see that's consistent is whether it's in transport, whether it's in routing and X-haul, as we've started to call it, or it's in the RAN itself, even in the core. This disaggregation idea is a pretty common one. The control plane, user plane, synchronization, management plane, having those separated is is a fundamental concept that has a lot of resonance, and outside of the 5G and mobile networks too. We see that in the broadband world also. And one of the reasons for that, again, is really the appeal of having this software-centric control strategy, embracing software-defined. It gives you opportunities to do different things with the network than we did before. So I think that's very relevant. In terms of challenges, I guess one thing I would add, Sterling, quickly is that today, incumbent systems that are already installed in the network, unless it's a network like Laley's, categorically they're not going to be disaggregated. Certainly in the 4G world, that was less common. In the core, we did some of that, but out in the edge mobile transport, we didn't. So there are two important considerations there. Making sure these systems can coexist, but also how you transition from one to the other. We have had to anticipate that in the design of our products. Laley mentioned merchant silicon. We use that in our products today for the data plane. But the network operating system framework has to be prepared for this idea of SDN control or of control plane separation. And that's really what's necessary to allow you to make the change from one to the other.
All right, excellent. Thanks all. I know we are getting short on time, as I knew we would run out quickly. Let me go to the last topic. Andrew, I'll let you kick this one off. You had already mentioned up front of your involvement in ORAN. So I wanted just to ask about open initiatives, open standards groups around the transport that are most relevant. And if you can kind of, identify them and then give why they're valuable. And then if you want to talk about the implications of ORAN on our topic of transport would be interesting as well.
Yeah, so it's a great point. The Open RAN idea, as we've already discussed, is about how you change the architecture of the network for 5G to help it scale, to embrace software-defined, all those kind of things. There is, as I suggested a moment ago, parallel initiatives that are happening in the transport world. And here I would say the capital T transport world, in terms of making systems interoperable, making them standards-based, and so forth. One of the key trends that we see in the transport networks, in the mobile transport networks at the far edge of the network, Laley said, historically those were sub 1 gig, now becoming 10 gig class networks. We actually see the new frontier of these networks being in the 100 gig class and above. And that higher order transport is something that we're used to having in the backbone, in the long haul networks, using DWDM, using coherent detection, all this kind of stuff. So there's definitely a trickle down of that technology to the access layer. But the fundamental question is how you make that appropriate for the edge of the network, how you scale it down, how you densify that kind of technology. That really gives rise to a disaggregated type of approach. And if you look at the Open ROADM MSA group, a lot of activity there about standardizing the optical modules, but also making them interoperable and having this notion of what are the control plane interfaces, how do we separate the control from the optical plane. Those are all things that are very relevant to what we're doing in transport and in 5G as well. So we'll see a lot of overlap and synergy, I think, between ideas like Open ROADM and disaggregation of the mobile network.
All right, excellent. And we are short on time. Alan, I'll give you the last word on this topic. I know from DCS, you're more broadly involved across the transport segments than Calix. As you mentioned, Alan, you guys are more focused closer to the user side. From your realm of involvement, which open initiatives groups are most important?
Well, I'm going to answer your question by not answering it. I would say one of the things I don't want us to forget is the role of organizations like the Broadband Forum and standards organizations who are open communities driving something which is a standard that is testable, repeatable, and the role, and Andrew used the word standards there, so I want to give a nod to organizations who are writing hard standards, because in the end, disaggregation's probably the payoff is at the interoperability between vendors within networks. And I think standards are going to achieve that in a in a quiet workhorse kind of way underneath the glitz and the glamour.
That's a good point. We could spend a whole session on that, but certainly the traditional standards bodies have been beat up over the past several years as we've moved to open. And I think what is a standard and not is just blurred quite a bit over the past several years. Some of these open initiatives seem to be standards, but they don't like the term. And then some of these standards are open, but they don't seem to be put in the same bucket. Great. Let's we'll close. Any last comments on the open bit? If not, we'll close out.
Sterling, I'll say something quickly. In
Sure.
addition about open, Alan brings a good point about standards. Laylee kicked this off and talked about OCP. There is actually a whole ecosystem of participants that have a new take on how standards translate into reference designs, use of merchant silicon, Telecom Infra Project. We mentioned ORAN Alliance. There's a long list of them. So I think that really reinforces the materiality of this trend, that this is where operators want to go. And that standards activity, even in BBF and the like, will become more practical. Plugfest, interop, practical demonstrations, physical hardware, prototypes, and that just helps us go faster. So we're definitely engaged in that way.
All right, excellent. Good final thoughts. All right, we'll close out here. I want to thank our panelists, our sponsors, DCS and Calix, and also Alan and Andrew for your insights, and of course, Laylee and AT&T for joining as a invited speaker on this one. Thanks, everybody. Hope you enjoyed the session.
Thank you.
Thank you.